All right, we're talking 5.8, solving radical equations. So again, remember the word radical. When we say radical, we're thinking roots, right? Square root, cube root, fourth root, fifth root, whatever that is, right? That's radical. Now, when we're solving, that means we're trying to get the variable by itself. Equations, you're going to see equal signs. All right, so a couple things to think about. Number one, always think about undoing what is being done to the variable. And second, here's the thought I'm going to keep saying over. Think undo using SAD map, which is the reverse order of operations, right? So what do I mean by that? Let's take a simple general equation. 2x plus 1 equals 11. Okay, so let's say that. So where's my variable? It's here. What's being done to it? It's being multiplied by 2 right here, and it's adding 1. Right? So when I think about reverse order, right, PEMDAS is order of operations. So SAD map is reverse order of operations. So what you do is you say, what is there any subtraction addition being done to my variable? Well, yes, there is. There is addition. So undo the addition. Okay, so then what would I do? I would subtract 1, and you do that from both sides to undo it. Then you would end up with what? 2x equals 10. Okay, now come back. Where's my variable? It's right here. What's being done to it? We are still multiplying it by 2. So if I go back up to the order of operations, do I see any subtraction addition being done to it? Not anymore. We already did that. So now let's look for division multiplication. Is there any division multiplication? Yes. It's being multiplied by 2. So undo it. Divide it. Well, whatever you do to one side, do it to the other side. So now we get x is equal to 5. And that takes care of my addition subtraction. Now we would try to get rid of any exponents we might see and then get inside the parentheses and then start working inside the parentheses. But those are non-existent, so we're good. And that would be your answer. So we're going to take that same approach, undo using order of operations. So here we go. Okay, so anytime that we see a radical, you treat that like a parentheses. So we want to undo that thing, okay? So as I look at this right here, I know it's blurry, and I apologize for that. X minus 9 is equal to 5. Where is my variable? It's in here. It's being done. The radical is trapping it. So we're going to undo the radical. So guess what we get to do? We get to multiply or take the left side and square it because it will undo a square root. But whatever you do to the left side, you have to do to the entire right side. So that will undo it. And so now we're going to have x minus 9 equals 25 because once you square it, you get the bigger number. Now we still need to undo, so it's being subtracted. So undo the subtraction, add 9. Right? So now that we have added 9, because now we're like inside the parentheses, so we just redo the whole process. Right? X equals 34. And that would be my answer, just one value right there. Okay, let's try this one. Okay, I need to undo the left side. Well, it's being square rooted, so let's just square the left side, which also means you need to square the right side. So that will free up my 3x is equal to 36. Let's divide by 3 on both sides. We get x is equal to 12. There we go. Okay, moving on to the next one. Ooh, it's a cube root of x minus 2 equals 2. How do you believe that you undo a cube root? That's right. You cube it. Cube root and cubing it will get rid of that. But then you got to cube the other side. So now here we go. We're going to have x minus 2 equals 2 cubed. That's 2 times 2 times 2. 2 times 2 is 4. 4 times 2 is 8. 8. Got to undo. So x equals 10. There you go. There you have it. Okay, so that's kind of that's the basics right there. Let's get into some more complex. Okay, anytime that we have multiple roots going on, separate them if we can. So we have big giant group on the left, big giant group on the right. But this is going to work out real nicely because if I need to undo the left side by squaring it, I need to undo the entire right side by squaring it. So everything's done by sides. Now this is awesome because it's just a whole square root square. So we get 3x minus 1 is equal to the square and the square root cancel, 2x plus 4. Now we're back to our generic, right? So subtract 2x from both sides. And in the same vein, let's go ahead and add 1 to both sides. That way I'm just kind of knocking these both out together. So I'm going to get what? X is equal to 5. All right, so nicely and easily done here. Okay, so here's the deal. Here's what I'm going to do here. I'm looking at the right side right this moment, and it's looking like I need to square it. So whatever you do to one side, you have to do to the entire other side. Now check this out here, folks. There's a base outside of a root, and then there is the root. So just make sure that the 2 is applied to the 2, or the square is applied to the 2, and the square is applied to that. So when we do that, I end up with 2 squared. The square and the square root go, so then it would be times x is equal to the square and the square root cancel, x plus 9. Okay, let's finish this off. 4x, 4, right? 2 squared is 4 times x is 4x equals x plus 9. Now let's finish. 3x is equal to 9, and so x is equal to, if we divide by 3 on both sides, we get x is equal to 3. All right? So that's what that looks like. But check that base that was outside. Do not neglect it. The square has to also attach itself to that. All right, here we go. We got fifth root on both sides. Fifth root, how do we get rid of the fifth root? You betcha, to the fifth power. Well, let's go to the fifth power. Well, this is nice. Fifth power, fifth power, fifth. And then we got x plus 4 is equal to 3x minus 2. And we would go from there. So subtract x. I'm going to add 2 to both sides, right? So that way I'm going to get rid of that and that. I'm doing that all in one step. So 6 is equal to 2x divided by 2. X is equal to 3. I'm reading that backwards. All right, so that's kind of how those go right there, right? So let's now get it a little more complex. If it's a little more complex, all right, I still see the cube, but this is the exact same thing that I was doing a minute ago. So I'm looking at the right side. I want to undo this big cube root, so we are going to do to the third power. But whatever you do, you have to do it to the entire other side, and this is super important to notice that there are two things. So the 3 must be applied to the 2. The cube must be applied to the cubed root. So then when you do it, it's going to be 2 cubed times cube root and cube will cancel on that, times x is equal to the cube root and the cube cancel, x plus 7. So notice this is the number that sometimes people forget about. Don't forget about it. So 8x equals x plus 7. So then we got 7x equals 7, x equals 1. That is our final answer. So just take note of that. Okay, this one. Oh, this is ugly. So, right, one thing that people might think, they're like, oh, let's just take this and square it. Well, you don't want to square this because these are two separate pieces. They're two groups. So that means you're going to be doing a FOIL process. Ugly. But you know what we can do? Instead of just squaring a whole side like that, what if we did this? Add the square root of 2x minus 4 to both sides. All right, so now let's rewrite it. So now I got square root of x plus 6 is equal to the square root of 2x minus 4. What do you notice now? Now, if you square the whole left side, and then you have to square the whole right side, square and square roots cancel. And now it's not near as complex as it might have been just a moment ago. Right? And now we're ready to continue to solve, which I'm not going to solve this right now. I think we got that pattern down. I'm just trying to get the square roots open. Okay, now let's look at this one. What do you suppose we need to do? I need to get rid of the square root. So how about we square? But whatever you do to the left side, you do to the right side. Square root and a square cancel each other off. So now you get x plus 56 is equal to x squared. Oh, man. What happens here? If I see a square, this is called a quadratic. And so the only way to solve quadratics is to think about some of the techniques. We can do factoring, quadratic formula, completing the square. All those, most of those require us to get everything on the same side. So here's what I'm going to do. I'm going to subtract that. I'm going to subtract that so I can get a 0 on one side. So that means I'm going to subtract x, subtract 56. So it's going to look like this. 0 equals x squared minus x minus 56. I'm going to do a quick factoring technique. Right? Do I know of two things that multiply to negative 56 and add to a negative 1? I do. How about negative 8 and 7? So it's going to be x minus 8 and x plus 7. But then we're going to set that equal to 0, and we're going to set that equal to 0. So we're going to have two answers on this. So you're going to have x minus 8 equals 0, and you're going to have x plus 7 equals 0. So you got two answers here, x equals 8 and x equals negative 7. All right, so that's what it's going to look like right there. And that way we get our answers. Okay, so that sometimes you're going to end up with quadratics, right? Especially when it's unbalanced. What I mean by unbalanced is we have a root on one side and we don't have a root on the other side. So then when we go to square the rooted side and you got to square the other side, you're going to create quadratics. We're going to create cubics. We're going to create something like that. So here we go again. I need to square to get this side. I'm going to have to square the entire other side. So square and square root cancel each other out, so that makes that pretty easy right here. Now, x minus 2 squared, what is that actually? So sometimes we need to redefine. This is x minus 2 times x minus 2. So you need to FOIL or double distribute in order to get answers. So we're going to get x squared minus 2x plus 4. All right, now let's bring everything back together. Actually, I see an x squared term, so I know I'm going to have to get a 0 on the one side. So let's start there. Subtract x and subtract 18. Subtract x and subtract 18. So that'll give us 0 equals x squared. Well, if I put all of this junk together, minus 2x minus x, that's minus 5x. And then we put these numbers together, minus 14. Okay, so that's what that looks like. Let's go into factoring mode. Let's see, are there two things that multiply negative 14 and add to negative 5? How about we do negative 7 and positive 2? So now you got x minus 7 equals 0, or you got x plus 2 equals 0. So what are our answers? X equals 7, x equals negative 2. Two possibilities there. Right? Do you kind of see how this is going to go? So the same thing on this one. If I needed to get rid of that, now I'm going to create a quadratic right here. And just remember that whenever you say x minus 3 squared, you mean x minus 3 times the group x minus 3. So just make sure you FOIL this out in order to get an answer. All right, and I'm going to bypass this for now, but you get the idea, hopefully, on that. Okay, so then lastly, let's just look at what happens when they do this. Well, we talked about this. We could either rewrite or just think about what's happening here, right? So let me talk about, let's do, what if we wanted to do the rewrite method? The rewrite method is really, what does that mean? It means the square root of x minus 5 equals 3. And now we're ready to square both sides, get x minus 5 equals 9, and we would solve from there. Okay, so that's the rewrite method. Or let's just keep it as it is, right? X minus 5 to the 1/2 equals 3. So how do we, essentially, we're just saying, how do you make a 1/2 equal to 1? Well, I would need to multiply this. Multiply 1/2 times 2. All right, so essentially what I'm saying is I am going to square this side, which means I need to square this side. Now, when you square that, it really becomes this. X minus 5, 2 times 1/2 is 1, equals 3 squared. Well, what is something to the first power? It just means it's itself. So x minus 5 equals 9. Right, so if you want to rewrite it, I mean, this is probably the most popular, just rewrite it. But you could just think about it keeping it as a fractional exponent, and that's okay as well. Okay, now let's do this one here. Again, if you want to rewrite it, it's going to be this. It's the cube root of 2x plus 1 is equal to 2. So how do we undo? Cube, cube. Those cancel. So you end up with 2x plus 1 equals 8. That's 2 times 2 times 2. And then we'd go from there and solve. And finally, here we go. If you want the rewrite method, you would call it square root of 4x plus 5. Or just say, I would take this whole side and square it, because now it's power to a power, so you're going to multiply those two powers. But if you square the left side, you have to square the right side. So you're going to end up with 4x plus 5 equals x squared. And then you would say, oh, I see a quadratic. I need to get a 0 on one side. So we would subtract 4x, subtract 5, subtract 4x, subtract 5. So then I would get 0 equals x squared minus 4x minus 5. Factor and solve. And we'd be done. All right, there you go. That's what you do. Undo a root with a power. And technically, you undo a power with a root. So that is what we would be working on.